Now we are discuss about the topic of transducer engineering unit number 5. It can be used in the other transducer and application. Most of the applications supported the transducer engineering. So many other applications are available in a transducer engineering. Is the first of all piezoelectric, Hall effective, magnetoelastic sensor, digital transducer, smart sensor, fiber optic sensor, film sensor, MEMS and nano sensor, smart sensor. Most of the applications are supported in the transducer engineering. We are discuss about that piezoelectric transducer. So piezoelectric transducer apply the pressure to the for summing the member. So getting the output. So crystal vibrating, getting the piezoelectric transducer, getting the outputs of the diagram. The piezoelectric material is the one which the electric potential appear across certain surface of the crystal. Is the dimensions of the crystal changed, the application of the mechanical forces. The voltage is produced due to the displacement of charge. This effect is reversed also by varying the voltage is applied proper axis to the crystal. It will be change the dimensions of the crystal, they are be deforming it. This phenomenon is known as the piezoelectric effect. So what are the material using in the piezoelectric transducer? Phosphate, ammonium dihydrogen phosphate, quartz, ceramics, made with the barium titrate, diphosphate theride, potassium dihydrogen phosphate, lithium sulfate. So the modes of operation can be using the piezoelectric transducer: thicknesses expansion, transverse expansion, thicknesses shear, phase shear. So 4 type of modes can be using the piezoelectric transducer. First of all, thicknesses expansion. Second one, transverse expansion, thicknesses shear, phase shear. So this kind of we can be using. The mode of the motion employed depends on the shape of the body relative to the crystal axis and the location of the electrode. The piezoelectric element used for the converting mechanical motion into the electrical signal may be through the changing the generator. Is the mechanical deformation generating a charge. This charge is applied the voltage across to the electrode. So output voltage we consider as the E naught. So E naught is equal to Q by C. The working operation of a crystal is placed between a solid phase and pore summing member. An extreme applied the pores entering the transducer through the pressure port. Applied the pressure at the top. So produced the EMF across the proportional to the magnitude of the applied the pores. The magnitude and polarity is induced surface changes, so proportional to the magnitude direction of the applied force. Q is equal to F into T. F means force in a Newton. D means crystal charge density, C by N. Crystal charge density is constant for given crystal. Force in Newton means F. The modes of operation. First we are discuss about the thicknesses shear. So diagram will be differ for the 4 modes of operation. So properly we can show the diagrams. So equivalent circuit of the piezoelectric transducer. So in input voltage, so Q charge will be applied to the parallel capacitance and parallel resistance. To output will be getting. So output voltage will be provide. So CP and RP is connected. CP means parallel capacitance, RP means parallel resistance. The source is charge generated and the value of charge is Q is equal to DF. Q is equal to DF. So charge generated across the capacitance of CP crystal and its leakage resistance is RP. E naught is equal to Q by CP. So Q we can substituting the value of DF by CP by changing the force divided by CP. So Q is substitute the DF by CP. So advantages: small size, lightweight, repeated construction, self-generating type of, no need to external power, output or quite have a good frequency response is the advantages. Where you using the application, force, pressures, temperature, high frequency of accelerometers. So lightweight process to most of the applications support the piezoelectric